Always important to read thoroughly the exploration part of each experiment. And in chemical reactions, the exploration begins with our learning objectives. Now, we're not going to meet all of these learning objectives because some of these learning objectives do not match what we're learning in our class. So, for example, we're not going to define an activity series. And you already know how to balance chemical equations, so we're not going to balance any in this lab. So first talks about chemical reactions, so definitely read that. And then balancing chemical equations, so this is all review but important to read over. And then exploring classification of reactions. So in our textbook we've seen decomposition reactions, and then we call this combination reaction a synthesis. So when you see the word combination in HOL, it means synthesis, where two things come together to form one product. And then we see our displacement, both a single displacement and a double displacement. Okay, so read through those as a review. And then here, exploring the activity series. This is not an objective for our class, so we're not really going to use the activity series too terribly much, but we are going to do a chemical reaction between metal and metal cations. Now this part of the exploration is super important that you read carefully. You may need to read it more than one time because part of your grade is going to depend on how well you record your scientific observations. And there are a few protocols that we follow. First, you're going to be observing these chemical reactions to see if there's any visual cues. Not all chemical reactions have visual cues or sensory cues, but some of them do. So one visual cue would be a change in color. If there's a change in color, that's a clue that a chemical reaction has occurred. Sometimes there may be a change in smell. That's a clue that a chemical reaction has occurred. You're not going to be able to tell whether a change in temperature occurs because the amounts you're using are so small, but this often is an indication or a clue that a chemical reaction is occurring. And then a precipitate. We haven't seen that word yet, but what a precipitate is the formation of a solid. And in these wells, which are really tiny, it might be hard to know if a solid is forming. You're going to look for something that is milky or opaque, and then perhaps after the hour or so that you're letting it sit there, a solid may settle to the bottom. So you're going to have to look very, very carefully to determine if a precipitate occurs. So it'll be something that looks translucent, something that looks opaque that you can't see through. And then formation of bubbles. Again, these wells are so tiny, it's going to be hard to determine if bubbles are forming, so you're going to have to look very, very carefully. Now, you will be recording color, and you want to be really careful about not using the word clear. We don't want to use the word clear because it's sort of ambiguous. Clear does not mean colorless. For example, these two Erlenmeyers are both clear, but they're also colored. So clear simply means we can see through it, and something could be clear and colored. So if something has no color, if a solution looks like water, we want to call it colorless. And if a solid has no color, if it's white, we also call it colorless. So that takes us through the exploration. You want to be sure to read those carefully and make sure that you are writing your observations according to scientific protocol.